We're going to do 7.3. Start off with this. And they said use x equals tangent of theta. Well, we see a 4 in both of these, and so it might be easy to factor that out. So let me just kind of show you how you could do that. So this would be the integral from 0 to 1, dx in the numerator. There's a 4 in both of these, but there's a square on this. So let's leave that square there, stay with inside it, and put 4 times the quantity 1 plus x squared. And now hopefully you can see that this would turn into 0 to 1. The 4 is squared as well as this quantity. They're both multiplied, so you can distribute the power there. You can't distribute it on these still. So the 4 would come out as a 1/16. And dx over 1 plus x squared. Quantity squared. So now, let's do this substitution. So if x equals the tangent of theta, dx is secant squared theta d theta. Drawing the triangle with the tangent being x over 1. The hypotenuse is 1 plus x squared. So actually what would be nice is just to call this the cosine of the angle happens to be 1 over the square root of 1 plus x squared. Normally we would write the secant of theta equals that square root thing because it would be the reciprocal. But since this is in the denominator, I might as well just call it the cosine. And then this would be not this squared, because that would be just the inside, but to the 4th. So this problem would become 1/16, the integral from no longer 0 to 1 because we're making a substitution. So if I put 0 in for x, the tangent of 0 is 0. And the tangent that equals 1, the tangent of pi over 4 is 1. And we have secant squared dx is secant squared theta d theta. And then this 1 over the square root of this is the cosine. But to get rid of the square root, we'd have to square both sides. And then to make it squared, we'd have to square it again. So this is going to be cosine to the 4th. And so we have 1/16 integral from 0 to pi over 4. Secant squared is 1 over cosine squared, so that would cancel 2 of the cosines, and we just have cosine squared theta d theta. Now, if you hadn't seen this, but went ahead and did what we normally do on this triangle and say that square root of 1 plus x squared, the hypotenuse over the adjacent is the secant, the reciprocal of the cosine. And so then this to the 4th would look like the denominator. So we'd put secant to the 4th in the denominator. And the secant squared would cancel 2 of them, and secant squared in the denominator is the same as cosine squared in the numerator. And they have a formula for cosine squared. Or you could use the half-angle identity and you get something out of this. But the formula, that's 1/16. Integral of cosine squared was a couple things. One of them was x over 2 plus 1/2 sine of the angle cosine. And this is an angle, theta plus c, but we're evaluating from 0 to pi over 4 in theta, so I don't have to convert that back. I could, but I'm not going to. And so I get 1/16. Pi over 4 over 2 is pi over 8 plus 1/2 sine of pi over 4 is square root of 2 over 2. Cosine of pi over 4 is square root of 2 over 2. So I got that. Minus 0 over 2 is 0. And sine of 0 is 0. Cosine of 0 is 1. 1 times 0 times 1/2 is 0. So I have just this, which is 1/16 times pi over 8 plus, this would be 2 over 8. And I could do some simplifying there, like pi plus 2 over 8 and take this 8 times 16, or I could reduce to 1/4, a bunch of things, but I'll just leave it like that. All right, number 30. Now there's some real similarities to number 30. We got an x squared plus 1, just like we had up here an x squared plus 1. So all of this can apply again. So once again, to do those, we do x equals the tangent of theta. We draw the triangle with the tangent being the opposite over the adjacent, which is 1. And this side becomes 1 plus x squared, or x squared plus 1. 1 squared plus x squared. If we solve for the square root, it's equal to the secant of theta. Or cosine theta is equal to 1 over that square root. And dx is going to be secant squared theta d theta. So we have the integral no longer going to be 0 to 1 because we're making a substitution. In place of dx, it's secant squared theta d theta. And this is the secant theta. And I've got to square it to get rid of the square root, and then cube it, so it would be secant to the 6th theta d theta. Now, since I've changed and I'm using the same thing and it had the same limits up here, it's going to be from 0 to pi over 4. And secant squared is going to cancel 2 of these and leave it secant to the 4th in the denominator, which is cosine to the 4th in the numerator. Oop, no d theta there. So this would become the integral from 0 to pi over 4 of cosine to the 4th theta d theta. And so we can do the reduction formula for cosine to the 4th. It's formula number 6, and this would become the integral, oops, excuse me, not the integral to start with, becomes cosine to 1 less, that would be 3 of x, sine of x over 1, let me underline it, over the power, which was 4, plus, and then it becomes 1 less, which is 3 over n4. the integral of cosine squared x dx. And then there's a formula for this. So we've got cosine to the third x sine x over 4 plus 3/4. And for the cosine squared, it is x. Oh, and we've changed the theta here, so these x's are all thetas. So these should all be thetas. Okay. Hard to keep everything straight. Over 2. Formula says x, and so that's why I did that. For the cosine 2 theta, the second formula says x over 2 plus 1/2 sine of x cosine of x, which is theta now, plus c, but we're doing a definite integral, which is from 0 to pi over 4 of all of this. So cosine of pi over 4 is square root of 2 over 2 cubed. Sine of pi over 4 is square root of 2 over 2. That's divided by 4 plus 3/4. And theta is pi over 4 over 2, which is pi over 8, plus 1/2 of sine of pi over 4 is square root of 2 over 2. Cosine of pi over 4 is square root of 2 over 2. So we got all of that minus, put in 0. Well, the sign of 0 is 0, so that wipes this one out. 0 over 2 would be gone, and sine of 0 is 0, so that's gone, so it's minus 0. So it's just what we got here. And what we have here is square root of 2 times square root of 2 times square root of 2 times square root of 2 4 times, so that's 4 over 8 times 2 is 16. So this is 4/16 divided by 4, which is 1/16, plus 3/4 of pi over 8, so that's 3 pi over 32. And then that 3/4 is also times this, which is 2 over 8. And I could do some reduction there, whatever, but good enough. Simple enough to look at.